Hi, everyone. I want to recommend to you that you uh, look at the practice quizzes in DocSharing. Uh, they relate to the material that is in the unit. This one happens to be for Unit 2. The answers are given, and it's good practice for you before you do the graded quiz. So I've looked at three questions here. I may not have time in seminar to go over some of this stuff, so I thought I'd use this video to get the information to you. The first one shows you a table, and it shows you a group of people that are categorized by gender, men and women, and age. And it wants to know that if you pick one of these people out at random from this group, what's the probability that the person you pick is a female or someone less than 41 years of age? And so the key word there is or. Or. And when you look at a probability problems, it's really important that you read it carefully because a little word like or makes quite a bit of difference. Now, an or formula in probability, which is in the textbook, is right here. It says the probability of either A or B, one event happening or another, there's the or, is equal to the probability that the first one happens plus the probability that the second one happens minus the probability they both happen at the same time. So to make life a little bit easier here, let's use this M, men, F for female. Let's call those of you who are between 25 and 40 years young, and those of us who are between 41 and 60 plus, we'll make that old, okay, just to make our symbolism a little easier. So what we're going to say is the probability that you pick out a female F or someone less than 41 years of age, which is a young person in the way I've gotten it, is equal to the probability you pick out a female plus the probability you pick out a young person minus the probability that the person you pick out meets both criteria, is female and young. And we need to subtract that and term because if we don't, we're going to be double counting. And so what we're going to do is add the rows here, and we're going to add the columns. We have 11 people who are young. We have 10 people who are old by my definition. We have 9 men and 12 women. So they add up, they agree that we have 21 total people in the room. So the probability you pick out a female, well, there's 12 of them, 12 females in the room, 12 over 21. And the probability you pick out a young person is 11 over 21 minus the probability you pick out a person who meets both criteria. They are female and young. So we have female, we have 5 who meet both criteria, you notice in that cell, 5 out of 21. So since our denominators are all the same, we can just add and subtract the numerators, which is 23 minus 5, which is 18 over 21. Simplifying it, we're going to get 6 over 7. That's the probability that we pick out someone who is either female or less than 41 years of age. Now, the probability, for example, that we pick out someone who is male and old, well, how many are there? Men, old. There's 3 out of 21. Or 1 over 7. What's the probability that we pick out an old person given that we picked out a female? Now this is called a conditional probability. This vertical line I drew here is an abbreviation for given that. In other words, what I'm saying is I told you we picked out a female. So now you're not interested in all 21 people any longer. Now you're interested only in these 12 females because I told you we picked out a female. Now, knowing that, what's the probability the person is old? Well, there's 7 out of 12 who are old given that they are female. That's called a conditional probability. Okay, let's go on to the next one. This next one is a binomial probability problem. We know it's binomial because it has the required terms of n, p, and x. N is the number of trials. Read it. We found that 45% of customers buy the Deluxe Joe. What's the probability that out of the next 10 customers, exactly 5 will buy the Deluxe Joe? Well, the total number of customers, the total number of trials here is 10. The probability of success, and here success is defined as buying the Deluxe Joe. The probability any one person will buy it is 0.45. And they want the probability that exactly 5 will buy it. Exactly 5. Well, how many people out of the 10 could possibly buy that thing? Well, sometimes it pays to put down all the possible outcomes. Out of the 10 people who come, none can buy it. 1 can, 2 can, 6 can, 9, 10, or maybe all 10 can. What they want is exactly 5. No less, no more. Exactly 5. Well, what we're going to do is we're going to go to Excel. And we're going to use Excel. There's a formula, but you don't want to do that. We're going to go to Excel, and we're going to go into Formulas, Insert Function, and I'm going to put down statistical as the category. And you notice there's a whole bunch. We can scroll down. We're going to come to binomial distribution right here. And if we say OK, it asks for 4 things. What number are you interested in? Well, that's at exactly 5, so we'll put 5 in there. How many trials are there? 10. Remember, you need to know N, P, and Q, or N, X, and P for every time you use a binomial. The probability of success is 0.45. Now, this last one, cumulative, what they want to know is, do you want the sum of probabilities between 0 and 5? Or do you want just 5? Well, we want just the probability that 5 do. So we're going to put in false. If you put in true, then it would add up the probabilities of no one buying it, 1 buying it, 2 buying it, 3, 4, 5 buying it. We don't want that. We want the probability exactly 5. It's 2340. 2340. It gives it up there right in the cell. 2340. So the probability that exactly 5 buy it is equal to 0.2340, which is the answer right here, by the way, 23.4%. Now, suppose we wanted the probability of 5 or less, in other words, this right here. Well, then what we would have done is we would have gone into our binomial distribution once again, and we would have, instead of putting in a false, we could have put in true. So let's go back here. And once again, we're going to go into the binomial probability distribution. Okay. And it's going to want to know the number we want. We said 5. The number of trials is 10. Probability is 0.45. This time we're going to put in cumulative, true. We want it to add up. And you'll notice it's 0.7384. 0.7384. 7384. And so 7384 is this probability right here. And the way we write that is the probability that the number of people who buy that thing is less than or equal to 5 is equal to 0.7384. Now, if you wanted the probability of this right here, this is the probability that the number who buy the product is greater than 5. Well, we know the total probability that between 0 and 10 buy it is going to be 1. One of that has to happen. And so the probability that x is greater than 5 is equal to 1 minus the probability that x is less than or equal to 5, or 1 minus 0.7384, or 6162, 26.16%, that more than 5 people will buy the Deluxe Joe. So again, using Excel it's quite straightforward, a lot better than using formulas, which we're not even going to mess around with in here. One more. This one deals with the normal distribution. The normal distribution. And whenever you see a problem that has these terms in it, is normally distributed, what you're allowed to do is you're allowed to sketch out the bell-shaped curve, the normal distribution. And this is talking about the variable, we'll call it x, which is gas prices. Okay? And what it says is that the average gas price, mu, that's the symbol for the mean or the average, is 378. And it says the variability, that should be standard deviation, sigma, is 5 cents. In other words, it varies by 5 cents. And so the middle of the curve, that's the mean, that's the median, that's the mode, is 378. That's the mean. We know the standard deviation is 5 cents. So let me draw this over. We can add 5 cents above the mean and get 383. One more, 388 is right here. And finally, 393 would be right there. It's 3 standard deviations above the mean. We could do the same thing below the mean. We could subtract a nickel from 378 and get 373. And then 368, and then 363. And so what they want to know is, what's the probability that the price of gas is going to be greater than 385? And the reason I like to sketch this out is because it tells you where you are. Here's 383, so 385, let's say, is in here someplace, right in here. And they want this probability right there. So right away you know your answer's got to be less than 0.5. Why? Well, this half of the curve has a probability of happening of 0.5, and the right half of the curve has a probability of happening of 0.5. And so since the area that we want is less than half of that curve, you know the answer's got to be less than 0.5. Just kind of gauges you and tells you where you are. Again, there's tables, there's formulas. We're not going to deal with those. Instead, we're going to go to Excel. And when we go to Excel, we're going to once again go into formulas and insert function, statistical, and we're going to look up normal distribution. Scroll down till you come to normal distribution. There's a couple of them right there. It tells you what it is for a specified mean and standard deviation. So x is the value in the problem. And you know they want to know what's the probability that we're going to pay more, 385 or more, 385 or more. So x is 385. And they want to know the mean, which is 378. Remember the standard deviation, the variability was 0.05, was a nickel. Now, cumulative. For a normal distribution, you always put in true, always. What this does is it tells you, and the answer is 9, let me record that, 91924. right there. What that does, it tells you that the probability, remember, we put in true. It tells you the probability that x is less than equal to 3.85 is equal to 0.9192. Let me write it down. 9192. Less than or equal. That's this right here. We don't want that. We want this crosshatch version right here. And so, as we did with the binomial, we know that this curve encompasses the entire data set, or a probability of 1. So if we want the probability that x is greater than 3.85, all it is 1 minus the probability that x is less than or equal to 3.85, or 1 minus 0.9192, 8080, or about 8.08%. That's the probability that x is greater than 3.85. And you can tell it's got to be a low number because it's in the tail here. There it is, 0808. So practice some of these. Use Excel. The more you do, the better you're going to become at it. If you have any questions, make sure you email me at afiducia@kaplan.edu.